let's continue about the elements of telescope. While looking through the telescope tube, we can see a virtual image of the rod while looking through eyepiece. We should remember that the virtual image of the territory is magnified and inverted. We can see crosshairs in the diaphragm. We use these crosshairs to provide visible horizontal and vertical reference lines in the telescope. And the line of sight means the line of collimation. We can use, with adjustment screws, the diaphragm can be moved in the telescope to adjust the crosshairs to the line of collimation. Parallax. When focusing the telescope, the real image formed by the objective lens is made to coincide with the diaphragm. What is parallax? When viewing two distant objects approximately along a straight line, and the eye is moved to one side, then the more distant object moves relative to the other in the same direction. This can lead to observation errors, wrong reading, wrong sighting. If the real image formed by the objective lens does not coincide with the diaphragm, a parallax is observed. The reading depends on the position of the eye. Focusing the telescope. Is anybody have seen Pirates of Caribbean movie? Huh? While we can see the ancient telescope, maybe in 17th, in 18th centuries, we have everybody used telescope tubes with external focusing. It means that the telescope has variable length. While changing the length of the telescope, we can establish image of the territory to put this image in focus. Nowadays, most of all, we use the telescope tubes with internal focusing. That means that special lens is moving inside the tube and changes the focusing. Tilting level. We have tilting axis that help us to move the direction of our sight up and down. We use so-called tilt and screw to change the direction of the line of sight and make it horizontal. We use bubble tube to make this line of sight true horizontal. Well, we also use clamping screw to fix the telescope in one vertical plane, and tangent screw to finally rotate the telescope along a vertical axis. The circular bubble help us to put the equipment in horizontal plan. But the bubble tube is more sensitive, and we can precisely horizont our instrument before we begin to measure heights and differences of heights. Well, here you can see an example of surveyor level. Sometimes this equipment has green color, made in green color, because sometimes they have been used in military purposes. Nowadays, a lot of instruments have bright orange color, because most of all we use the geodetic equipment in civil engineering while making maps and plots of the territory. Here you can see Carl Zeiss Jena brand. It is a German company which is well known their optical equipment. Well known of their optical equipment. That it means that it's very this equipment have very best quality of lenses and all the optical stuff. Well, in the times of Soviet Union, there are few geodetic equipment factories and plants inside the USSR. It was Ural optic mechanic plant, and another one was in Izum in Kharkov region, optic mechanic plant, and some equipment has been developed at the Arsenal military plant in Kiev. Nowadays, the market of geodetic equipment is rapidly changing, and I will give you some example of modern international companies that share the market of these instruments. Well, tilting level has a very interesting um, it has constructed very smartly. We have the image of the bubble that projected using a mirror or prismatic coincidence reader. While bubble you see at the left, while bubble tube is tilted, and in the right you can see bubble tube is horizontal, because this prism reflects the opposite sides of the bubble in one ocular. So we can make precisely horizontation of the telescope, and the line of collimation, so the measurement will be very precise, and it will have high quality. Well, the setting up the level consists of a few steps. First of all, we fix the level on a tripod. I think that everybody knows what does it mean, tripod. It's consists of a head with 3 legs, and we can change the orientation of the head using special screws. We use circular bubble by adjusting the foot screws to approximately level the instrument. Here you can see the explanation: circular bubble, Treibach, foot screws below the Treibach, and then we put our level instrument onto the Treibach, and then we can precisely make our line of sight horizontal. Another step, next step is sight the leveling staff. First, rotate the telescope in the direction of the staff. Second, use the fine motion screws to ensure precise sighting. On some instruments, the fine motion screw works only when the alidad is fixed. The next step, adjust the leveling bubble using the leveling screw. Nowadays, there are many instruments with automatic level. Automatic level has no tilting bubble at all. We just stand the instrument in horizontal position with not very big accuracy, and then the automatic horizontal device begins to work. Um, and then we can automatic level contains an optical device which compensates the tilting of the telescope. We should call it compensator. Um, the working with automatic level is more quickly. We can work with automatic level much more quickly because the using tilting level takes a lot of time. Here you can see example of automatic level. You have only one circle a circular bubble level in the on the top of the equipment, and then while the bubble stands in the 0 point in the center of the glass, we can continue or begin our observation and see the rod in our the image of the rod in our ocular. Well, in this slide you can see the operation of the compensator. Faster observations, eliminations of possible reasons of blunders. However, the compensator has also disadvantages. Vibrations, wind, traffic, etc. have a bad impact on the operation of the compensator. Here you can see precise leveling rod. We put it on a foot. This means that the rod can stand still, and the measurement of the heights will be precise and will have good quality. Let's move on and speak something about adjustment of levels. First of all, we in this test, so-called two-peg test, we can discover how much is the collimation error. Collimation error alpha is when the line of collimation is not horizontal, when the level is leveled. Firstly, we should establish a test line on an approximately flat surface Then compute the elevation difference between test points A and B. And then the effect of collimation errors when the shoulders D1 and D2, so-called shoulders of the station, when these shoulders are equal, the height difference is also not very big, just it's not goes far from zero. Then we should move the instrument to an external point on the extension of the AB line. Here you can see. And then compute the elevation difference from the observations. Note that the elevation difference contains the effect of the collimation error. Then we can calculate the difference, the catet of the triangle, which is which occurs because of this collimation error. The true elevation difference is already computed from the previous configuration, and thus the collimation error is can be calculated using this equation. Let's think about error sources. We can distinguish two types of errors. Systematic errors. First, systematic error is effect of curvature. Since the equipotential surface is approximately spherical, the effect of curvature is a function of the instrument staff distance. When the backside and foreside distances are equal, the effect of curvature cancels out. So we should try to put the instrument in the middle of the distance between A and B rods. We should to make the shoulders of the measurement equal. In this case, the effect of Earth's curvature cancels out. Another systematic error is refraction. The air has different optical properties everywhere. Air pressure, humidity, etc. This has an impact on the refractivity. Thus, the light does not propagate along a straight line, but along a curve. You can see in the picture air layers of different temperature. The hot air is near the surface in the summer, and then when we the distance between the layer of the air and the surface of the earth much bigger, the air is much colder. And that is why Willibald Snellius, an ancient geodesist, explains this law, and that is why we should try to make the systematic error not very big, not very much, not very big. For points with the same elevation, the effect of refraction can be neglected. So we should not use very big shoulders, and the numbers that we read on a road must not be very small. The line of sight should not go through the hot air near the Earth's surface. So while we are leveling upon a slope, we should make the shoulders on every station not very big. In this case, the line of sight will be in the cold air, and the refraction will not affect our measurement. Here you can see a radius of a refractive curve. The instrument should be set up exactly in the middle between 2 points, thus the effect of curvature is the same for backside and foresight. The effect of collimation error we also should put the instrument exactly in the middle between 2 points, and the collimation error must be constant, thus the effect is eliminated. Tilting of the staff. A rod, we called every rod the staff while leveling, should be vertical, should have vertical position. This effect depends on the tilting angle alpha, and reading, the higher the radio reading is, the bigger the error is. So often we ask our another surveyor who is standing with the rod to tilt the staff in the different direction, and the smallest reading will be the true reading. Staffs should be equipped with the circular bubbles and kept vertical. Another option is a circular bubble that is stand directly on a rod. Settlement of the tripod. Measuring the height difference between A and B. We can make the reading A1 and then reading B1. While the tripod is standing on the warm, on the wet land, on the sand, and did not settled properly, the measuring the height difference can have an error delta H. This delta H is an error that occurs because of not proper settlement of the tripod. Another option we the measurement of the height difference between A and B and B consists of two parts. Firstly, we measure difference between A and B, make the reading A1 and B1, and then another part of the operation is measuring difference between B and A. We write down reading B2 and A2. So finally, the mean value of the delta H will be free of the height difference error. The reading should be taken in both order, and the mean value of the height difference should be computed, assuming constant observation speed. Settlement of the staff. The problem is the staff has a subsidence during the observations. A change plate must be used to support the staff. All lines should be run twice in the opposite directions. A change plate must be used to support the staff. Well, this change plate we call the shoe in Ukrainian, because we stand our rod onto the shoe, onto the change plate. And this change plate helps us to make the staff, make the rod more immovable. Graduation error of the staff. Well, the problem is the centimeter graduation of the staff is not accurate. The units have different lengths. Solution: staffs must be calibrated regularly. The gradation must be checked in laboratories. Index error of the staff. The problem is the bottom of the staff is not aligned with the zero unit of the scale. The effect of the index error on the reading is L equal L plus D plus delta, where L is the reading taken, while delta is the index error. You can see in the picture this small delta. The effect of index error on a single height difference. You can see the equations when only one stuff is used, then the effect of index error cancels out. However, often we use two different rods, two different stuffs, and so this effect of index should be taken into account. What happens when two stuffs are used? Single height difference here. The sum of two height difference is here. And then the systematic error is occurs. When two stuffs are used, an even number of stations have to be created in the leveling line. In this case, the effect of index error of the stuff cancels out. You understand even number. The number of stations should be 2, 4, 6, 8, 10, 11, etc. Procedure of leveling. The instrument must be set up with the same distance to the stuffs. The bubble tube must be leveled before each reading, tilting level. You must not use the parallax screw between the backside and foreside reading. While the instrument in the middle of the line, we should not use the parallax screw because each rod is in focus of our telescope, because the shoulders or distances between the instrument and the staff are equal. The bubble tube must not be affected by strong heat. Well, you probably know that while heating, every material becomes bigger. The temperature size changing, so the heat affects the changing of the size of hot material. So the bubble tube must not be affected by strong heat. Often we can use umbrella to protect the instrument against the strong heat, against the sunlight. Readings must be taken 30-50 centimeters above the ground. You probably remember that it helps us to avoid the refractions errors caused by refraction. The hot in any case, sometimes while we are in hurry and try to read the readings below 30 centimeters, the image of the rod can be cannot be read because you probably have seen this effect over highway when the cars are riding onto the highway, and in the summer when the weather is hot, you can see how the hot air goes up, and this effect of not proper picture. We cannot see the picture is not standing. It just change. The picture changes is changing rapidly every second because of hot air. Next rule: stuff should be set up vertically. Next rule: a change plate should be used to place the stuff on the ground, and leveling must be done in two opposite directions. Nine step: all the observations should be made with a constant speed. Observations should be made only in suitable weather. Well, a cloud sky, constant temperature, early morning or late afternoon. It is not good idea to make observation in the time not far from the 12 o'clock in the afternoon, because the weather is very hot and the errors grow rapidly. Next step: the stuff should be calibrated. If there are 3 hairs in the diaphragm, one should use all of them to take reading. So we use only one hair line in the diaphragm. When two stuffs are used, an even number of stations must be used to create the leveling line. Line leveling, detail point leveling. So the principle of leveling: what happens when we want to measure the height difference of two distant points? We just rotate the instrument to the back rod, write down the reading, then we rotate the instrument to the front stuff, write down the reading number 2, and then we rotate the instrument to the back stuff, and then we write down reading number 3. This three reading we have read over the central hair. Another hairs, additional hairs here helps us to measure the distance between the instrument and the staff. This procedure, so we have six readings on every station. Let me explain you why I am speaking about six readings. Well, we have different two different kinds of leveling rods, of leveling stuff. The wooden stuff and much more precise Invar stuff. This can be an aluminium stuff with the Invar strip, Invar strip with the graduation. While we are using the wooden stuff, it has two sides, black one and red one. And we make readings of the red and black sides of the stuff. Another case is when we use modern stuff. In this case, we repeat the previous procedure as many times as need to cover the distance between the points. Here you can see the direction of leveling forward, and then we repeat the procedure backward. So we can get the haze difference twice in the forward line and in the backward line, and in this case we can get much more precise result. Processing leveling data. Line leveling one way. Sometimes we use one-way leveling. It means that we have the leveling line from A to B in the one way. We put the point number, back staff, forward staff, rise, fall, and the heights of the points. Uh, well, while we stand on the between the point A and the first shoe, um, I will show you how this shoe how is it looks like. Uh-huh. Yeah. Uh, Here you can see the leveling stuff is put directly on this you can see different kinds of this leveling shoe. Mm, it has three small legs and the round surface in the middle. And while we put the rod on this circle surface, it helps us to avoid mistakes. Is it clear? Well, mhm. Well, we put the level instrument between the points A and 1, write down the distance between the stuff, and write down the back stuff and fore stuff, and then we calculate the difference between these readings and understand that the heights become smaller. It means fall. Then we move, we put the first rod on the point 2, on the point 2. We write down the distance between two stuff and put write down the reading from the instrument to the back staff and to the force staff, and calculate the rise or fall, just back staff minus the force staff. Always we calculating the difference from the back staff minus the first staff. It means the fall when it has well, the third station, we put the stuff from the point 1 to the point 3. We calculate distance using our distance hairs in the crosshair. We write down the readings for back staff and fore staff, and in this case you can see the small rise 0.561, and the last station in the section, from point 3 we put the stuff from the point 2 to the point B. We measure the distance. It is 13 meters. Then write down the reading to the back staff and to the fore staff, and can calculate the fall from the point 3 to the point B. Then we cross red line and calculate the sum of rises and falls, and then we calculate all the summary of the work. In the survey departments, we often make the two-way leveling. It means that we go the line from A to B in one direction and backward in another direction. In this case, all the rises in one direction will be false in another direction. All the numbers will be very similar, but will have the opposite signs. Well, in one direction we have minus 0.505, and in the opposite direction plus 0.511. And then we should calculate the mean value of the height difference between points A and B. Let's compute the mean height difference. Well, detail point leveling, the height of collimation method. Detail point leveling, the elevation of some detail points, characteristic points of object should be determined. The elevation of the characteristic point of the ditch should be determined. Well, heights of collimation, the elevation of the horizontal line of sight, it can be computed by adding the elevation of the backside point and the backside reading. You can see example of rise and fall method, and here heights of collimation method. Well, have you any questions? 12, 13, 15. We have 15 minutes. Well, this presentation is pretty good, and I will share this presentation with you, and you can look through. Well, how can we share this? Well, I put this presentation to the Google Classroom, and you can use it